بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 6.1, area between two curves. Set up an integral for the area of the shaded region and then evaluate the integral. Well, I will set the integral. I will leave the evaluating for you because we studied how to evaluate definite integrals in chapter 5. Well, here I have a region. This is a function y, this is another function y. If I choose a vertical rectangle here, I will notice that the width of this vertical rectangle is delta x. And if you move this rectangle to the right and to the left, always the red curve would be above the blue curve. So I have this equation. The area between the two curves would be given by this equation, AB integral from AB of f of x minus g of x dx, where f of x is above the graph of f is above the graph of g of x, which is always the case here. So f of x in this case is 3x minus x squared minus g of x, which is x, and dx, and x is from 0 to 2. Okay, so x from 0 to 2. This is also another question. If I choose a vertical rectangle also with width dx, then always e to the power x is above x squared. So the area would be given e to the power x minus x squared dx, and x from 0 to 1. So this will give you the area. Of course, you can evaluate the integral easily, ex minus x cubed over 3 and from 0 to 1, and you find the answer. Here, notice that if I choose a vertical integral, then in this area, in this region, this curve is above this curve. But now here it changes. This one would be above this one. Taking a horizontal rectangle here is the clever choice. Maybe it's yeah, the nice choice here, because delta y here is the width, and if you move this rectangle up and down, always the red curve is to the right of the blue curve. In this case, the formula is given by a equals f of y minus g of y, where the functions here are solved for x. So we have x equals f of y and x equals g of y, and the f of y is always to the right of g of y, and this is integration with respect to y, and y runs from c to d, which is the case here. So I have f of y, which is e to the power y. This is to the right of y squared minus 2. Now we will subtract, so it would be minus y squared plus 2 when you subtract. The minus sign will change the sign of y squared and the sign of 2 dy. And now you notice y from where to where? Y from negative 1 to 1. So these are the borders of the region on the y-axis from negative 1 to 1, and you can continue and find the area. Again here, choosing a horizontal rectangle is the choice, and delta y here is the width, and the red curve is always to the right of the blue curve. So a would be integral of the red curve is given by 2y minus y squared minus the blue curve, which is y squared, and minus will change the sign of 4y dy, and y is from 0 to 3. And of course, you can write it from 0 to 3, negative 2y squared and 2y plus 4y is plus 6y dy, and then you find the integral as usual. Now here, uh, I will choose uh, a, a, a vertical rectangle, but I have two regions, okay, two regions. In this region, uh, this curve is above the line in all the area, in all the region, and here the line is above the curve. So I will use uh, delta x as width, vertical rectangle. So uh, the first region, the integral is from, uh, we have x cubed minus 3x. This is the above curve minus the line, which is y equals to x, dx, and x is from -2 to 0. So this is the area of the first region, plus. Now here x is above the curve, which is x cubed, and minus times minus is plus 3x dx, and x here is from 0 to 2. And you can just find the first area and multiply by 2 because the two areas are equal, as we can notice. So this would be integral of x cubed minus 4x from -2 to 0, and integral of 4x minus x cubed from 0 to 2, and you find the answer. Now we don't have graphs, we are given some curves, and we need to set up, do not evaluate, he said set up, but do not evaluate an integral representing the area of the region enclosed by these curves. So we need to graph this region first to uh, understand what's going on. So we have y equals to 2 to the power x. Well, let us graph this function. If x is 0, then y is 1, 2 to the power 0 is 1. And if x is 1, y is 2. Okay, so this is the graph of this function, 2 to the power x. Y equals 3 to the power x. 3 to the power 0 is 1, so it also passes by this point. And 3 to the power 1 is 3. So this would be the graph of 3 to the power x. X equals 1. Well, x equals 1 is this line. Okay. Here, make sure that at 1, 3, 3, let us say, okay. This is the line x equals 1, and 3 should be here. So I'll just uh, draw a better graph. Yeah, this is e to the power 3. So you can see that this is the area between uh, 2 to the power x and 3 to the power x, and the line, the vertical line, x equals to 1. Well, you can notice that uh, if you take a vertical rectangle, moves from right to left with width delta x, then always 3 to the power x is above 2 to the power x in this region. So the area would be integral 3 to the power x, it's above 2 to the power x, okay, dx, and x is from 0 to 1. So this will give you the area of this region. Another uh, two functions. I have 2 minus x, this is a straight line, and I have 2x minus x squared, this is a parabola. It's easy to graph uh, the line. 2 minus x. I put x 0, so y is 2. This is the y-intercept. And if I put y 0, then x would be also 2. So this is, you can sketch the graph of the line. It passes by these 2 points. Now this parabola, if I write it y equals negative x squared plus 2x, I can see that it opens downwards, and a is negative 1 and b is 2. So h would be negative b over 2a, 2 times negative 1. So negative 2 over negative 2 is 1, and k would be, I replace x by 1, negative 1 plus 2 is 1. So 1, 1 would be the vertex of this parabola. So 1, 1, and it opens downwards. Well, I can also find, since it opens downwards, I can find the x-intercepts. So if I put 2x minus x squared equals 0 to find the x-intercepts, I have, if you take x as a common factor, then 2 minus x equals to 0. Then the x-intercepts are x0 and x2. So this parabola passes by 0 and by 2, like this. Okay, executes my graph. Now, what else? If we find the intersection points between the curve and the line, we should get these two, 1 and x equals 1 and x equals 2. Let us check to make sure from our calculations. We can also find then the intersection points by putting the two equations equals to each other and solving this equation. Now I'll take everything to the left hand side. So I'll have x squared minus 2x minus x plus 2 equals 0. Then x squared minus 3x plus 2 equals to 0. And either you use the calculator or you factor x minus 1 times x minus 2 would be 0. So this will give you the factored form of this. So either x is 1 or 2 as we have seen. And now if you put 1 here, 2 minus 1 is 1. So this is the first point of intersection. And if you put x2, 2 minus 2 is 0. So this is the second point of intersection. So actually, the area between these two curves would be this one, the small one here. Okay. So if we make it bigger, this is the line, and this would be the curve. Okay, this is the line, and this would be the curve, and this is the region. So you notice that in all of this region, I can find that the curve, the parabola, is above the straight line. So if I take a vertical uh, uh, rectangle with width delta x, it would be fine. And I can then write the integral as the integral or the area as an integral from x runs from 1 to 2, and the parabola is 2x minus x squared minus the line, which is 2 minus x, so it would be plus x dx, and then you can write it negative x squared. 2x plus x is 3x minus 2 from 1 to 2. This will give the area of this region. Sketch the region enclosed by the given curves. Decide whether uh, to integrate with respect to x or y. Draw a typical approximating rectangle and label its height and width. Then find the area of the region. Y equals x squared plus 2. That's a parabola. 2 units up. So it goes like this. Y equals negative x minus 1 is a line. If x is 0, y is minus 1. This is the y-intercept. If y is 0, then x is negative 1. So this is another y-intercept. So I have a line here, okay, passing by these points going up. and x equals to 0. This is the line x equals to 0, and x equals to 1. So this is the line x equals to 1. Okay. So between x equals to 0, this is the line x equals to 0, and x equals to 1, and this curve, and this line. So this is the area enclosed by all of these curves. Well, if I choose a vertical rectangle here, then always this curve would be above this curve. So the best choice here, or the choice, is to choose a vertical rectangle with width delta x. And the height would be always this function minus this function. So the height would be x squared plus 2 minus x plus 1. So it would be uh, minus x plus x, and minus 1 is plus 1. So this would be the height of this rectangle. Notice if you choose a horizontal rectangle, you have to divide this area into different regions because, for example, here, this line is to the right of this, and then this line is to the right, and then this line is to the right of this curve, while a vertical rectangle will just finish the question in one step. So the area would be x squared plus 2 plus x plus 1, so I can write it x squared plus x plus 3. This is curve minus line dx, and x is from 0 to 1. And uh, you can just evaluate the integral easily. Y equals x cubed plus 1. This is, we know the graph of x cubed, and plus 1 will take the graph 1 unit up. This is the graph of x cubed like this. So plus 1, the point 0, 0 will go up, and the graph would be like this, okay, like this. This is the graph of x cubed plus 1. Y equals 2 minus x. This is a straight line, okay. Uh, if x is 0, y is 2. And if y is 0, x is 2. So this is the line, okay. And x from x equals -1. Well, if I put -1 here, -1 cube plus 1, it would be 0. So also this curve passes by -1, okay? So if this is -1, then the curve passes by -1, and I have the line x equals -1. This is the line x equals -1, and x equals 0. So let us now determine the region. The line x equals -1, okay, this is the line, and the line x equals 0, and the line y equals 2 minus x, which is will continue the graph of the line 2 minus x. Okay. So this is the line x equals 0. This is the line x equals -1. This is the line y equals to 2 minus x. And this is the curve. And yeah, this line should be just in purple. This is the y-axis. So this is our region. This is the curve. This is the line y equals 2 minus x, x equals -1, x equals 0. So this is the region. Again, you can notice choosing a vertical rectangle here will finish the problem in one step. The width is delta x. The length would be the line above the curve, so 2 minus x minus the curve, so it's minus 1 minus x cube. So this is the height of the rectangle. So in this case, the area would be given by, uh, we can just simply yeah, write this in simplest form, negative x cube minus x, and we have 2 minus 1 is plus 1 dx, and x is from negative 1 to 0. So this will give you the area of this region. Here, y equals x minus 2 to the power 2. This is a parabola. uh, Taken 2 units to the right. Okay. We know the graph of a parabola y equals x square, but negative 2, it would be the parabola taken 2 units to the right. And y equals x, this is the curve with, this is the line that passes by 1, 1, and 2, 2, 2, and 0, 0. This is the line y equals x. Now these two curves will intersect, okay? And I would like to know where is the intersection between them. So let me find the solution of this equation. Let me equate the two curves and solve this equation. So I have x squared minus 4x plus 4 equals x. So x squared minus 4x minus x minus 5x plus 4 equals to 0. So x minus 4 times x minus 1 equals to 0. 4 minus 4, yeah, that's the factors form. So either x is 4 or x is 1. So the intersection points would be 4, and I put x 4, y would be 4. So 4, 4, and 1, 1. So they intersect here at this point. So this curve goes like this. It passes by 1, 1, okay. And 4, 4. So 3, 4, it goes up to 4. So they will also intersect here. So now I have this region between the line and the parabola. Uh, you can notice that the line is always above the curve. So if I just choose vertical with vertical rectangle, delta x is the width, and the height would be x, which is the line, minus x minus 2 squared. Uh, so this will give you the height of the rectangle, and then I can write an integral to find this area. It would be integral of x minus, of course you can يعني expand this. You can write it x minus x square minus 4x plus 4, and then x minus x square plus 4x minus 4, and then it would be negative x square plus 5x minus 4 dx, and x is from 1 to 4. So this will give you the area of this region. I have a parabola here, y equals x squared minus 4x. A is 1, b is negative 4, so h would be negative b, so it would be 4 over 2a, so it would be 2. To find k, I replace x by 2, so 4 minus 8. 2 square minus 4 times 2. 4 minus 8 is negative 4. So the vertex of this parabola is 2 and negative 4. And then I have the line y equals to 2x. So 1, 2, 1, 2, 3, 4. This is the vertex of the parabola. Coefficient of x squared is positive, so it opens upwards. Okay, and the line y equals to 2x. It passes by 0, 0. If x is negative 1, then y is negative 2, okay? And if x is 1, then y is 2. So this is the graph of this line. Now, they intersect where? The intersection between the line and the parabola. So x squared minus 4x equals 2x. So x squared minus 6x equals to 0. So x times x minus 6 is 0. So they intersect at x equals to 0 and x equals 6. Well, if x is 0, then 2 times 0 is 0. And if x is 6, 2 times 6 is 12. So in fact, I need 3, 4, 5, 6, and this will go up to 12. So they will intersect here at this point and at the point 0, 0. So this is the intersection between them. So this curve would go like this and like this. Okay. So this would be the area between the curve and the line. And as you can see, a vertical rectangle will solve the problem here with delta x, and the height would be the line minus the curve, the parabola. Negative x squared plus 4x, so it would be negative x squared plus 6x, and the integral will give you the area between negative x squared plus 6x dx from 0 to 6. From 0 to 6. Okay, I have here a parabola, but y square. So this is a horizontal parabola, and this is also a horizontal parabola. Okay, so let me start by this one. It is x equals negative y square plus 1. This is a horizontal parabola. A is negative 1, B is 0. So K here is negative B over 2A, which is 0. And H would be, if I put 0, replace Y by 0, K represents Y, so X would be 1. So the vertex of this parabola is 1 and 0, this point. And negative, so it opens to the left. So the graph of this parabola will be like this. The other parabola, x equals y square minus 1, a is 1, b is 0, so again k is 0, and h is negative 1, so the vertex negative 1 and 0. So this is negative 1 and 0, and it opens to the right, so it will go like this. And they will meet somewhere. So let us find their points of intersection. So I have 1 minus y square. This is the first x should be equal to the second x, which is y square minus 1. Okay. And if I bring y square here, I'll have 2y square. And if I take 1 there, I'll have 2. So actually y square is 1. So the solution y is plus or minus 1. Okay, so y is 1 and y is negative 1. Let us find x. Well, you find it from anywhere. Let us use this one. 1 square minus 1, this is 0. Negative 1 square is 1 minus 1 is also 0. So they intersect at the point 0, 1, at the point 0, negative 1. So this is the graph of this parabola, and this is the graph of this parabola, and this is the region between them. Now, should we use a horizontal or vertical rectangle? If I use a vertical rectangle, I have to divide the region into two regions because here this is above this, but this is above this and the other one. But if I use a horizontal rectangle here, horizontal rectangle, okay, with width delta y, move it up and down, always this curve would be to the right of this curve. So the length of the rectangle here would be this curve, which is uh, 1 minus y square minus this curve, which is y square minus 1. The minus will make the minus plus. So 1 plus 1, 2 minus 2y square. This would be the height uh, or the length of the rectangle. So the area would be given by the definite integral 2 minus 2y square dy, and y here from negative 1 to 1. This will give you the area. Uh, Here, sketch the region enclosed by the given curves and find the area. So this is a parabola, y equals negative x squared plus 12. So it's a parabola opens downwards and taken 12 units up. So you know the parabola y equals negative x squared goes like this, plus 12, so it's taken 12 units up. So this is the graph of this parabola. X squared minus 6, this is the x squared, you know the graph of it, but it's taken 6 units down. So they will meet somewhere. Let us find their intersection points. Negative 12 negative x squared minus x squared equals x squared minus 6. So if I bring x squared here, I have 2x squared equals 12 plus 6, which is 18. So x squared equals 9, x equals plus or minus 3. So at x is 3 and at x is negative 3, they will meet. If you change x by 3 here, 9 minus 6 is 3. So this is the first intersection point, this point, 3, 3. And the other intersection point is negative 3 and 9 minus 6 is also 3. So negative 3 and 3. So they will meet at this point. Okay. So this is the graph of these two parabolas. Now, this is the region. If you choose a vertical rectangle, with delta x as the width, then always this curve is above this curve, and the height of the rectangle would be 12 minus x squared, which is the above curve, minus x squared plus 6, which is the below, the curve below. Of course, this is a plus because there is a minus, so a negative 2x squared plus 18, and the area would be negative 2x squared plus 18 delta x, and x is from negative 3 to 3. X runs from negative 3 to 3, so that's the integral of this area. This will give you the area of the region. X equals 2y squared, this is a horizontal parabola. X equals 4 plus y squared, this is again a horizontal parabola. Okay. 2y squared, this has 0, 0, the vertex, 0, 0, and it goes to the right. 4 plus y squared is also a parabola that opens to the right, and you can imagine, and it's like this, and it will go for units somewhere to the left maybe. But let us use our method. Let us write it in the form y squared plus 4, and a is 1 and b is 0, so k is 0 and h is 4, so 4, 0. So actually it moves 4 units to the right. Okay, 1, 2, 3, 4. So now 4, 0, and it opens to the right. So this would be the graph of this parabola. Okay, so there are two parabolas. They will meet somewhere. So let us find their intersection points. 2y squared equals 4 plus y squared. So 2y squared minus y squared is y squared equals 4. So y would be plus or minus 2. So they meet here. Okay, so there is something wrong then. If x, this parabola opens upwards, that opens to the right, and this parabola also opens to the right. They should meet 4y squared, 2y squared minus y squared. Okay, y plus or minus 2, nothing wrong. they will meet here and here. Okay, so if y is 2 and if y is negative 2, what would be x? Put y2 here. 2 times 4 is 8. Put y negative 2 here. 4 times 2 is also 8 because 4 times 2 is 8. So when x is 8, you have to go to 8, 5, 6, 7, 8. When x is 8, they will meet at 2 here and here. Okay, so the graph wasn't really correct. Now we will do it correctly. This parabola will go like this, will pass by this point. That's the graph of the first parabola. And the second parabola uh, starts from here and it passes by also this point. This is the point of intersection. So we have this region, this region. If you take a vertical rectangle will not work, you have to divide. But if you take a horizontal rectangle and move it everywhere, always this curve would be to the right of this curve. So the height, the width of the rectangle is delta y, and the length of the rectangle in this case would be this one minus this one. This one is 4 plus y square minus 2y square. So 4 minus 1 minus 2 is minus 1, so it's 4 minus y square. So the integral uh, of 4 minus y square dy, where is y now? From negative 2 to 2. This will give you the area of this region. Another question, y equals x minus 1. This is uh, the square root of x going 1 unit to the left, to the right. Minus 1 unit to the right. So this is the graph. X minus y equals to 1. This is a line. If y is 0, x is 1. And if x is 0, y is negative 1. And it will go like this. So they will meet somewhere. And let us find where they meet. So here I have x minus 1 equals y. Okay, and here y equals square root of x minus 1. So I have square root of x minus 1 equals x minus 1. Square both sides, so x minus 1 equals x square minus 2x plus 1. I have x square minus 2x minus x is minus 3x, and plus 1 is a plus 2 equals to 0. So x minus 2 times x minus 1 would be 0. This is the factored form. So either x is 2 or x is 1. So if x is 1, if x is 1, y would be 1 minus 1, 0. And if x is 2, 2 minus 1 is 1, the square root of 1 is 1. Good. So at the point 1, 0, they intersect. Okay, they intersect here. And at the point 2, 1, they also intersect. So the line will go like this, while the curve would go like this. Okay, like this. So it's a small area between them. To make sure that actually the curve is above the line, I can choose one point here, 1.5, okay, one value, one x value, and replace this. So square root of 1.5 minus 1, so it's square root of zero point 0.5. Square root of zero point 0.5 will give you 0.7, 0.71. While if I put 1.5 in the line, if I put x 1.5, so 1.5 minus 1 would be zero point 0.5, so y would be zero point 0.5. So this tells you that zero point 0.7 is greater than zero point 0.5, so actually the curve, the square root is above the line. And now if you choose, let us make it bigger than, this is almost the area between them. If I take a horizontal, uh, sorry, a vertical rectangle, then always this curve would be above the the line. So delta x is the width, and the height would be square root of x minus 1 minus the line, okay, which is minus x plus 1. So the integral would be, the area would be given by this integral, x minus 1 minus x plus 1 dx, and from 1 to 2. Once you sketch the graph, then it would be easy to evaluate. Y equals x cube, I know the graph, and y equals x. So y equals x passes by 1, 1, and 2, 2. Y equals x cube passes by 1, 1, but 2, 8. Okay, 2 and 8. So here, and negative 1, 1 also, they pass, but negative 2, 8. So this is the graph of x cube, and this is the graph of y equals x. So there are two small regions here, as you notice. It's also, this is the line, and it's doing like this, the curve, and doing like this too, okay? If I have two regions, so I find the integral like this. Of course, a vertical rectangle here will do the job, okay? In the first, let us start by this one, this one. The curve is above the line, okay? From negative 1 to 0, plus from 0 to 1. Now the line is above the curve. So this will give you the area of the two regions. Now I have y equals square root of x. I know the graph passes by 0, 0, 1, 1. And I have 1 over 3x. Let me make it, maybe we need to make it bigger. So this is 1 and this is 1. Okay, the square root passes by this. From 0 to 16. Okay, so we will go from 0 to 16. So we cannot do like this. Let us go up to here. So let us this make 16. So this is 1, 2, 3, 4. This is 5. And this is 10, 15, and this is 16. From 0 to 16. Well, if x square root of 0 is 0, square root of 16 is 4. So this would be the graph of y equals square root of x. 1 over 3x. If x is 0, it is 0. And if x is 16, y is 16 over 3. Well, 16 over 3 is 5 point something. So this is 4, so it's 5 point something. So it's here. So the line is above the curve. Okay. From 0 to 16, so this region will be there, x equals 16. So I have two regions, this one and this one. And a vertical rectangle will do it. And the area of this region would be the square root is above the line. But we need to know this. What is this x? What is this point, intersection point? So let us find the intersection point between these two. If I multiply by 3, so 3 square root of x would be x. And if I square now, so 9x would be x square. And then x square minus 9x is 0. So x times x minus 9 is 0. So x equals 0 and x equals 9. So actually at 9 here, they intersect. So from 0 to 9, and plus from 9 to 16. Now from 9 to 16, the line is actually above the square root function. So these two integrals will give you the two areas. One more exercise, additional exercise. I have the line y equals x. It passes by 1, 1, and negative 1, negative 1. And I have the curve y equals 1 over x. Uh, at 1, it is also 1. At 2, it is half. Okay, at half, it is 2. So this is the curve. Also here, okay, negative 1, it is negative 1, so it passes by this point. Here it is half, and here it is half. So this is the graph of the curve 1 over x. Now 1 over 4x, this is a straight line. Now if x is 4, y is 1. So it goes like this. Okay. And also if x is negative 4, y is negative 1. So it continues. It continued the line in this direction. So this is the line. Okay. And the regions between this and this and this is this one. Now this is the curve 1 over x. This is the line y equals x. And this is the line y equals 1 over 4x. Also here, this is the line 1 over 4x. And this is the region. This is the curve 1 over x. And this is the line 1. This is the line y equals x. So I have these two regions, and the two regions are identical. So if we just find one of them and multiply the integral by 2, so I will do that. Now, uh, if you take a horizontal rectangle, you have to divide the region into two regions. And if you take a vertical rectangle, also you have to divide the region into two regions. So I will choose a vertical rectangle. Now here I have two regions, this one and this one. So the area of the first region would be, I'm taking a vertical rectangle, so from 0 to 1. Now this curve, which is y equals x, is above the line 1 over 4x dx in this region, okay, in the first part. In the second part, which is from, this is 1, okay, which is from 1 to 2. And let us make sure that this curve, which is 1 over x, meets 1 over 4x at actually at 2. Let us check that because we did not find the intersection points between 1 over x and 1 over 4x. So uh, if I multiply by 4, I get 4 here. And if I multiply by x, I get x squared here. So cross product. So x would be plus or minus 2. So actually, yes, they meet at 2 and when x is 2 and when x is negative 2. So we said we multiply the integral by 2 because the two areas are identical. So I will multiply here by 2 and here by 2. So actually x is from 1 to 2. And now the curve 1 over x is above the line 1 over 4x dx. And remember the integral of 1 over x is ln x. You can evaluate the integral and find the area. Thank you very much. I hope you enjoyed listening to this lecture.